Hello. Okay, today I am going to solve this question IPL 2021 match day 2. Okay, how I could get to know this approach. Let me go with the basics. Let this test case, for example. What I did, there is a an elements of array indexes. Uh, what we need to find is we need to find the maximum element for each subarray. For example, this for this subarray we have maximum element is 3. For this subarray, we have maximum element 3. For this particular subarray, we have maximum element 3. For this particular array, I have maximum element 4. It is so easy if we go with the for loops, but as per constraints, we have to solve it in a big of n iterations. First time is about 6, and if we go multiply it and raised to n square, then it will be TLE, time limit exceeded. To resolve this issue, I have used diq. Why I use diq? In diq, it gives an operation where we can insert element from both front end and back and pop the element from both sides, from front side and from back side. So I'm using what I'm storing in dq. I'm storing the indexes for the element. Why indexes? I will explain later. Uh, let's let's start with uh, this particular array. What doing is that uh, um, what I'm doing is that the last element, just wait a second, at the back of the take the last element should be the maximum element, and at the front I'm storing the minimum element. So all I need to do is let me show the code for you. In the last element is a maximum element. Of course, last element would be a maximum element. The front element would be a minimal element. So I'm just I'm just accessing the last maximum element. So here I'm accessing the last maximum element q dot pop back, and you clearly see whenever I reach the window of size k mm, greater than equal to 3, I'm start iterating my solution. Now let's go with this portion. How I came to know I should go with this? Let me start from basics. Let's say if I have zero element, then there is no sense of doing nothing. Just no, I can compare any element because it's a use empty. I'm just pushing the front index, that is zeroth index in the queue. Let me start with this. Let's start with the example. For example, uh, initially I have q. I push the element q0 in the array. Then I push q1 index, and then I push q2. Whenever I reach When I push 1, Q0, after that I push Q1. At Q1, I will compare whether 2 is greater than from first index or not. If it is greater, then obviously I am pushing that element at the end. Again, then I reach the element 3. Then I again compare if it is greater than or greater than the Q top element or not. I'm seeing that Q3 is greater than 2. So Q of ARR represent 3 and ARR top here representing 2, which is obviously greater than 3. So I'm pushing the 3 index at the end of the queue. Okay. Here I can clearly see I have reached the top, I have pushed the top 3 elements in the array. So what I'm doing, I am copying the last element, mean to say accessing the top maximum element in just window of size 3. So I'm printing 3 here. Then after that, what I'm doing, uh, then when I get to the one element, then I compare the array. One is basically less than the front element. So what I'm doing is that I'm I'm get to in this first array is not an empty. So I will check one whether one is greater than uh, mm, last element or not. No, it's not greater. Then basically one is less than uh, or one is less than the maximum element. So I'm going with the front side of the queue, die queue. Queue is initially not empty. Of course, queue is not empty. Queue dot front is one, which is not less than means one is not greater than this element. So I'm just pushing that element in the queue. Then queue becomes in queue attend it in this. It will store the element in the front side queue.1. That is basically the index 3. And next at the next stage, what I'm doing, I will again popping the maximum element of that window that is comes out to be 3. And next, let me write it here, make things more clear. Then I get to know the element 4. 4 is basically greater than the 3. So it will push the element 4 at the end. And q becomes q dot 4, 4 index 4. Then I will access the element, the maximum element is at end. So I will print the maximum element that is 4 here. Then again I get to another element 5. 5 is again greater than this. I will simply push 5 at the end and it will be accessing it. Also I need to take care of that the last element is in a range or not. I think it doesn't even matter. And again 2. 2 is basically 2 is basically window. In this window, I get to know that 2 is basically linear less than that element, but the twist is that q is greater than 1. Q is greater than here what I'm storing. Storing I have element 1, here I have element 1, here element 3, here I have an element at index 1 is 2, element 3, next element 4, and here I have 5. Then I clearly see 2 is greater than, so I will keep popping this element. Here we clearly see Q is not empty. Q the front is less than the current element, so I'm popping it. Again, pop this element is less than no, so I am storing it in the front side. P of 6, it will store 2. Again, I'm going to know 3, which is 7. I will print the maximum element that is 5 currently. Then again pop this element 2 because I am 3 is greater is not empty. Again pop this 2 not empty. Q dot push the maximum element that is 7 here and that element is 3. Dex is 7, element is 3. Again I get to know 6. 6 is greater. Q dot Q dot last element is 6 and element is 8. And again 3 the maximum element that is one index that's 6. Yeah, and we can clearly see it is completely equivalent to our resultant element. You can see I had did not came to get this statement. This is basically checking if the last element is in the range or not. Let's say, mm, let me frame this with one short example. Let's say I have this window. What I'm doing is one. I have window size 3. Uh, Q of 2 is 3. Q of 1 is 2. Q of 0 is 0. No, 0, 0. What I'm doing, I have inserted the three elements and pop the maximum element. Again, I get to the 1 is less than. So again, what I'll do, I'm pushing the last element. Okay, in the front. Again, I'm pushing the last element in the front. If I let's say one more element I need to insert, then what it will do, it will retrieve the maximum element, which should not be the case. It should not be the case because we have at this array, but it will be popping the maximum element. So at this array, I'm comparing if three, the last element I am accessing, is in a range of not. That is basically current index 5 minus the the size of the window, that is basically 3, which is equivalent to 2. 2 is equivalent to this index. That means it is out of my window. So I need to pop this element first. Then I will retrieve the maximum element, that is 2 here. And I can show the output of this code, that is acceptable code. Okay. It will clear the rough sketch to make things more clearer. I can store it in answer array, just printing here. Uh, it gives me basically I'm not again to this. Okay, let's again with this. Yeah, it's acceptable. Okay, thank you.